Okay, so to calculate the molarity of N2 in the blood in contact with different pressures and determine the volume of N2 released whenever a deep sea diver ascends to the surface, we can use Henry's law. Okay, this relates gas concentration in liquid to its partial pressure. So this is the formula that we used where C equals concentration, K is Henry's law, and P is the pressure. So for me, it's really helpful if I just write down everything that was given to me from the problem. So that's what I did there. And then I calculated the molarity of each pressure that was given to us. So the molarity at the 4.0 pressure, ATM pressure. So I took 3.8 times 10 to the negative fourth, because that's what was given to us as Henry's constant for, I believe it was N2. Yeah, right there, N2. And then I multiplied that by the pressure, which gave us 1.52 times 10 to the negative third. And then I found the molarity for the unit of 1 ATM. So this was the second concentration. That just multiplied by 1, so it would stay the same. But then you have to change the moles. You have to discover the change in moles of N2 when P decreases and the pressure decreases, and when the diver ascends and goes up to the top of the surface. So I know that change in moles, so I just put the delta to represent change, and then N to represent moles. And then I did the number we got up here minus this number to get us our change of 1.12 times 10 to the negative third molarity. And then the next step was to determine the volume of N2 released by using the ideal gas law. So I converted 37 degrees Celsius to 310 degrees Kelvins, because that's the unit you need when you're using the ideal gas law. This is all assuming that the reaction would react like an ideal gas, because you never know, it might not. So I took our change in mole number that we just got up here, and I multiplied it by this constant and then the temperature and divided it by 4. This got us to 0.0074 liters. This was the amount. This was the amount released from 5 liters of blood as the diver ascended to the surface. Sorry, hopefully you can see that. And then I converted it into milliliters just so I knew it. And then I did have to look up the volume, how to find the volume of a circle again, because I forgot. So the volume of a bubble is 4/3 pi r cubed. So then this was also given to us. And so I plugged that in, and that got us to 5.24 times 10 to the negative 10th. And that would be the volume of one bubble. But then you have to convert this to liters. So then you just take the square away, and then it is 5.24 times 10 to the negative 7th. So then to find the bubbles per liter, I took this number from up here that we've already solved for, and I divided it by this number right here. And then I got 1.41 times 10 to the 4th bubbles per liter, which is about 14,100 bubbles per liter of blood when the diver ascends from 100 feet to the surface. That's all for question 1. Thank you.